So hello everyone, we will start a new chapter of chemistry class 10, that is acid, bases and salts. So this is a very fundamental chapter, and this will be required by you in class 11 and 12 very badly and very conceptually. So first of all, I will start our discussions with acids. So remember, in earlier classes we have learned many things related to acids. Acids are proton donors, the substance which have replaceable hydrogen atom in it, or which can donate hydrogen in the solution, which can produce hydronium ion. There are various concepts or definitions related to acids. One is called Arrhenius concept, another is called Lowry-Bronsted concept. Many concepts are there. So up to class 10 we will be learning. These are proton donors. Remember, proton donors. That means which can donate H plus ions in the solution. Or we can write it like this. They are the substance which can produce hydronium ion, that is H3O plus ions in solution. Or these are the few concepts related to acids. And remember, now many examples of acids are there. You know all those things. That is, we can write HCl. It can be dissociated into H plus Cl minus. This you have done up to now. Now we will be learning this same relation like this, HCl plus H2O. So you will be, and see here I am writing the reversible sign. So you will be writing H3O plus Cl minus. This is the hydronium ion. So similarly, we can write another example of this one. These few examples learn it very properly. 2H plus SO4 minus 2. Or in other words, we can write H2SO4 plus 2H2O. They can produce 2 units of hydronium ion H3O plus SO4 minus 2. So these are the few things. Now we'll start our discussion with classification of acids. So classification of acids. What are those? In many ways we can classify acids. Remember, acids can be classified in many ways. So first we will start with respect to their source. That means from where we can obtain the acids. So on the basis of the source, see, here we are classification on the basis of source. Source means from where you can find the acid. So there are two categories. One is called organic acid, another is called inorganic acid. So I can distinguish it, organic acids, and here it is inorganic acids. Now see, the acids which are obtained from living sources. Organic, the word means living organ. We will be having organic chemistry. So the acids which can be obtained or derived from plants, animals, these acids are called organic acids. So organic acids are derived from living organisms. So they can be obtained from living sources. They can be plants, they can be animals, or like this. So examples are you can take citric acid, tartaric acid, lactic acid, all are example of organic. Acetic acid, I can tell you, this is known to you, acetic acid, etc. So this is organic acid, the acids which can be derived from living organisms, and inorganic acid derived from minerals. So here for inorganic acids, they can be obtained from minerals. So these are easy examples. We all know hydrochloric acid, sulfuric acid, nitric acid, all are examples of inorganic or mineral acids. So first of all, with respect to the source from where the acids can be obtained, acids can be derived or classified into two categories, organic and inorganic acids. Now another type of classification of acid is on the basis of molecular composition, means how the acids is made or what are the composition of acids. So remember, in few acids only the active element is hydrogen, in another few acids there are some oxygens. So according to the molecular composition, remember, according to the molecular composition, acid can be classified again into two categories. One is called hydracid, which contains only hydrogen, remember, which contains hydrogen. And remember, all acid contains hydrogen, but here no oxygen, that is main thing, no oxygen, that is called hydracids. And we can give examples of hydracids as say HCl, all the halogen acids. Remember, the acids of halogens, that is examples are hydrochloric acid, hydrobromic acid, hydrogen bromide, hydroiodic acid, all you can see they contains no oxygen in them. That's why they are called the hydracids. And the next category is oxyacids. So the acids which contains along with hydrogen oxygen with it. So which contains oxygen along with hydrogen. Remember this one, hydrogen. So what are the examples? Many examples are there. Say nitric acid, HNO3, H2SO4, that is sulfuric acid, all are examples of oxyacids. Now the classification is on the basis of strength. Classification of acids on the basis of strength. Remember, with respect to this, acid can be classified basically into two categories. One is called strong acid, another is called weak acid. See here, so we can classify here the acid according to their strength as strong acid and weak acids. Remember, weak acids. So what are strong acids? Remember, the strength of the acid and base depends on the ion producing capacity. Ion in electrolysis, we have learned little bit about this one. So the acids which can produce large, and remember, learn this thing very properly, because exactly the same thing is applicable for base also. So the acid which can produce large number of ions in the solution, in which the dissociation takes place with a very large proportion. So strong acids are the acids which can produce large number of ions in the solution. So in other words, I can write where the degree of ionization or dissociation is large. So degree of dissociation means ion producing capacity is large. is large. So what are the examples? We all know, say HCl, it is a very strong acid. So it can produce very easily large number of ions. Say HNO3, it can also dissociate like this, NO3 minus. Say H2SO4, so you can write 2H plus SO4 minus 2. So here all the acids have high value, or remember this thing, high value of alpha. And what is alpha? We have learned that is called dissociation constant. So number of dissociated molecule divided by number of undissociated molecule, you can recap it from your electrolysis chapter. And weak acids are the acids which produce less number of ions, which produce, remember, which produce less number of ions in the solution. So remember here the degree of ionization, that is alpha value, is less than 30%. This is the information I am giving you. So main thing is less number of ions. Normally remember inorganic acids are strong acids and organic acids are weak acids. Examples are, remember, organic acids. Organic acids. What are those? Say I can take acetic acid. Acetic acid. I am giving this example because you know this acid. A CH3COOH. They remember that is the dissociation is little bit different from earlier acid. And other examples are lactic acid. All are examples of weak acid. So according to the strength, acid can be dissociated into two categories. One is called strong acid and another is called weak acid. Now on the basis of concentration, again this is easy thing. Acid can be classified into two categories. One is called dilute acid, another is called concentrated acid. So here, dilute acids and another is concentrated acids. So what are dilute acid? Remember, the acid in which the percentage of water is more, that acid is called dilute acid. So here we can write percentage of water is more, and similarly percentage of acid is less. And here in concentrated acids, the percentage of acid is more than the percentage of water. So here we can write percentage of acid is much greater than water. So remember this one. So percentage of water is more, that is called dilute acid. And remember, we use this concentrated acid and dilute acid according to our requirements. So dilute acid, remember, dilute acid is frequently used in the laboratories and other methods because concentrated acids are, remember, the dissociation of dilute acid is more than the concentrated acid. And if you want to convert a concentrated acid into dilute acid, so what to do? To add some water to it. And remember, acid should be added to the water, not the reverse one. That is, you cannot add water to the acids. Now the new classification of acid is the classification of acids on the basis of their basicity of acids. And in class 7-8 we have learned about basicity of acid. What is basicity? That is number of replaceable hydrogen ion, not number of hydrogen ion. So basicity means number of replaceable hydrogen ion in solution. Remember, that means how many hydrogen ion acid can produce. Depending upon this, the acid can be classified into basically 3-4 categories: monobasic acid, dibasic, tribasic, and after that we will term it as polybasic acid. So the classification will be like this. First is monobasic. Monobasic. What is that? The acid which can produce only one hydrogen ion can produce only one hydrogen ion in the solution. So it is the key word, one hydrogen ion. So we can take example as HCl. See, HCl can produce only one hydrogen. Say HNO3 nitric acid, it can also produce only one hydrogen ion in the solution. So this is our monobasic acid. Next comes dibasic acid. So I can write dibasic. Di means two. So which can produce two ions in the solution. So this type of acid can produce two ions in the solution. So I can take example of H2SO4. We all know that is sulfuric acid can produce two hydrogen ions in the solution. So that is remember another example of dibasic acid. Now I can write tribasic acid. So tribasic acid means can produce three or more. So we can write it as polybasic also. Polybasic. In some books they have given that polybasic acid, but remember, so this is tribasic acid. Can produce three hydrogen ions in the solution. And when they tell you polybasic, three or more. So I can take example of H3PO4, that is phosphoric acid. So remember, this is 3H plus PO, that is phosphate radical. So this is like this. See, H3BO3, orthoboric acid. So 3H plus BO3 minus. So on the basis of basicity, acid can be classified into these categories. So one related question regarding the basicity of an acid. This is a very frequently asked question in ICSC. See here, acetic acid. You all know the formula of acetic acid is CH3COOH. Contains 4 hydrogen atoms. See, 3 hydrogen and 1. But although it is a monobasic acid, so explain. This is a 2-mark question, remember. And remember, the basicity of the acid is the number of replaceable hydrogen ions. So remember this, you should answer it like this. Basicity means basicity of an acid is the number of replaceable hydrogen ion. So this is the keyword, replaceable hydrogen ion. Although CH3COOH contains 4 hydrogen atoms, but in solution it can release only 1 hydrogen ion. So dissociation of CH3COOH. So COOH is like this. That is CH3COO minus plus H plus. So this hydrogen ion, or you can rather write it like this. If you wish, you can write it like this. CH3COH plus H2O. You can produce CH3COO minus plus H3O plus. So although acetic acid contains 4 hydrogen ion, but in solution it can only replace 1 hydrogen ion. Hence acetic acid is a monobasic acid. So we can write, hence it can produce only can produce one hydronium ion. Write it like this: H3O plus ion in the solution. Hence it is a monobasic acid. Remember this one, and this is a very, very important question in view of your ICSE. Now everyone see, I have changed the heading. Up to now the heading was acids. Now the heading is acids and bases. So remember the categories or the classifications what we have done in case of acid. Exactly same thing will be going for the base. That is, base also can be classified into strong base, weak base, concentrated base, dilute base, and in case of base that will be acidity of base. I will be coming to that afterwards. So first of all, there are few concepts of acids and bases. Remember, few scientists have given different definitions or different propositions for acids and bases. Amongst them, a very important first one is Arrhenius concept. So acid base, this is Arrhenius concept. Arrhenius concept of acids and base. Remember, Arrhenius, the scientist name, and here the substance which dissociates in aqueous solution to produce hydrogen ion. So the substance or the compounds which dissociates in solution to produce H plus ion, hydrogen ion, are called acids, and which produce OH minus ion are called bases. So the continuation, hope you are interested, you understood this one. If they produce hydrogen ion, they are called acids, and if they produce OH ion, are called bases. And if you want, you can write, in place of hydrogen ion, you can write H3O plus, that is hydronium ion. This is Arrhenius concept. So next is Lewis Bronsted theory. So next concept is Lewis and Bronsted concept. So you will be learning more about more concepts in higher classes. So this concept is told that acids are, remember, proton donors, and bases are, proton means H plus ions. So I can write it, acids are proton donors. Same ultimate, altogether they are same. And bases, remember, bases are proton acceptor. So remember these two things very, very properly. We will give few examples of this one. Now see a very important discussion regarding acid base. So we have learned about Arrhenius concept, we have learned about Lewis Bronsted concept. Now I'll show you how water can produce hydronium ion in case of acids and OH minus ion, that is hydroxyl ion, in case of base. So before that, I'll start with water. So we all know in chemical bonding we have done this. Water, hydrogen is 1, so 1, oxygen is 8, so 2, 6, so H2O will be like this, H, oxygen 1, you can put a dot like this, and this one, and hydrogen is this one. So these are the bond pair electrons. So water molecule exists as two lone pair of electrons. So it is a polar molecule. So oxygen being more electronegative, all the charge will shift towards oxygen, so that will be delta plus, that will be also delta plus, and this will be minus 2 delta or 2 negative, and there are 2 lone pairs of electrons. This is the structure of water molecule. Now see, when water molecule reacts with acids, I have taken the, so with water molecule reaction with acid, so I can taking the acid as say HCl, that is hydrochloric acid. Now see how it works. So first of all, water I will write it like this, HOH, and there are 2 lone pairs of electron, and this is plus, and minus 2 delta, and it reacts with HCl. So hydrogen is delta plus, chlorine is delta minus. So remember how it works. Remember, this hydrogen moves towards this one, attacks this one. So see here what the product is. We are having the product. What product we are having? We are having, see, H, and there are 2 lone pairs of electrons. So this is, and you can see here, this is H3O plus ion, that is hydronium ion, and this Cl removes as Cl minus ion. So by this way we can say that with acid always water molecule forms this hydronium ion, that is H3O plus. Now see with bases, what happens with bases? So with bases, I am taking the example of ammonia, NH3. Now we have learned chemical bonding, so that will be easy for you. So I am drawing this like N, that is hydrogen, that is H. There are 2 lone pairs of electron, and with water molecule, this is a base. See how it is a base, we can conclude it will produce say OH minus ion. So water, I am drawing it like this. This is water molecule. So this is minus 2 delta, this is plus charge, plus delta, and this is plus delta. So remember, one of the hydrogen will go and attacks here to form the hydronium ion. So this is minus 2 delta. So see, N3H plus hydrogen will yield hydrogen N, that is H, and H. That is your ammonium ion. Now see what is the rest portion. From this water molecule, this hydrogen gone. So OH is the rest. So here you can clearly see OH ion is formed. This is ammonium ion, NH4, and you have, what is this? Remember, this is nothing but ammonium hydroxide. You have learnt it in chemical bonding. So here easily you can see on reaction, this is very important, many times it was there. So acids on reaction with water produce hydronium ion. Base, that is a base, with water molecule it produces a hydroxyl ion. So this is the supportive example of Arrhenius theory. Now we are continuing our discussion related to acid, bases and salts. Now we'll start the preparation of acids and bases, and I'll try to do it simultaneously, means together, so that you will be able to memorize it little bit easy. So we will remember acids always can be obtained from metals and non-metals, and bases always can be obtained from metals. That's why metal oxides are basic oxides and non-metallic oxides are acidic oxides. So first preparation of acid, so you should write from non-metals, and these are the things you should remember very properly. So I am taking very easy example of one non-metal, that is H2 plus Cl2, that is 2HCl, that is hydrochloric acid. Similarly H2 plus I2, that is called hydroiodic acid, and together the hydrogen when mixed with halogens, that is chlorine, fluorine, bromine and iodine, they are called halo acids. Now bases from the metals. Remember, bases up to now we have learned bases as OH, means the calcium hydroxide, CaOH all twice, NaOH, all are examples of bases. But remember, there are metal oxides are called basic oxides because in reaction they produce the base. So I can write base number 1 from non-metals, from metals, I'm sorry. So this is a confusing thing. So I can write it 4Na. I am writing the balanced equation plus O2, oxygen. So that produce sodium oxide. So this is 2Na2O. So sodium oxide is a basic oxide. Similarly, I can write magnesium plus oxygen. They produce, you can write equal to all our balanced equation 2MgO. These all metallic oxides are basic in nature, basic oxides, remember. So this is the first preparation of acid and base. Next you will start acid from acidic oxides. So number 2 is acid from acidic oxide, acidic oxides. What are acidic oxides? Remember, I have told you non-metallic oxides are acidic oxide. Non-metallic oxides means carbon dioxide, sulfur dioxide, phosphorus oxide. All are example of non-acidic oxides because they produce acid on reaction with water. Now see here, say I am taking the example of carbon dioxide. When it reacts with water, they produce H2CO3, that is carbonic acid. So I can take the example of sulfur dioxide. When it reacts with H2O, that is H2SO3, that is sulfurous acid. Say another example I am taking, plus H2O, that gives you H2SO4. And remember, these are acids which are obtained from acidic oxide. Acidic oxides means non-metallic oxides. Now, for base, same type of thing for base. Base we can obtain from basic oxides. So number 2 is from basic oxides. Basic oxides. What are those? Remember, metallic oxides are basic oxides. So I am taking the example of K2O, that is potassium oxide. When it reacts with water, so when it reacts with water, it produces 2KOH, that is the potassium hydroxides. Similarly, I can take Na2O, sodium oxide. When it reacts with water, it produces 2NaOH. Those are the bases which we can obtain from basic oxides. Now acids and bases from salts, remember. So first, number 3 I will start, that is acids from salts. So remember, few salts on reaction with acids, they produce different acids. So see here, so this will be there. See, potassium nitrate when reacts with H2SO4. This reaction, the same reaction will be there in your nitric acid chapter. If the reaction takes place less than 200 degrees Celsius, then partial decomposition takes place. See here, below 200 degrees Celsius, it is called partial decomposition. So we all know that H2SO4 is a dibasic acid, but here it dissociates below 200 degrees Celsius like this, H plus HSO4 minus. So here the product is, remember, KHSO4 potassium bisulfate plus HNO3 nitric acid can be obtained by this reaction. Similarly, if I take, say, NaCl, sodium chloride, on reaction with H2SO4, here also below 200 degrees Celsius and above 200 degrees Celsius. We will come to that in other chapter, that is compounds. That is, here you can take sodium bisulfate NaHSO4 plus NaCl. So NaHSO4 plus HCl. So these are the preparation of acid from salts. And now remember, when you prepare bases from salts, you will be taking this type of salt. Remember, and remember normal salts are. We will come to that normal salt after this, because the chapter is acid, bases and salt, and we are learning base. So bases from salts. So see here, from salts, how you can obtain bases. There are few bases on reaction with base, another base. Say I am taking an example of the salt is iron chloride, ferric chloride. When it reacts with sodium hydroxide 3NaOH, another base is produced, that is FeOH whole thrice. In analytical chemistry, we will see this type of precipitate will be obtained plus 3NaCl. So one base produce another base. So another example I can take it like this, that is AlCl3. Aluminum chloride, when reacts with sodium hydroxide, same reaction 3NaOH, it will produce aluminum hydroxide, AlOH whole thrice plus 3NaCl. That's how we can prepare acid and bases from salts. Preparation of acids and bases. This is acids by oxidation of non-metals. Remember, this is very important reaction. Say I am taking a non-metal as sulfur. Sulfur, when reacts with nitric acid 6HNO3, remember these balancing are very, very tough in the exam hall. So you have to prepare that one. So that will produce sulfuric acid, water and nitrogen dioxide. So you can write H2SO4 plus NO2 nitrogen dioxide plus water. So just I am balancing it. So it will be 2, it will be 2HNO3. I am just checking the balancing. So 6 and this will be 2. Check the balancing. So here you can see our acid reacts with a non-metal to produce another acid. Now see, by decomposition of salt, here we can obtain not the base, I am telling you the basic oxides. Basic oxides are also, remember, metallic oxides and hydroxides are called bases. Remember, this is another thing I am telling, that is, remember, metallic oxides and hydroxides are bases. So how we can obtain here the basic oxides? So how? So if we heat PbNO2, this is another important reaction, 2PbNO2. So it will produce lead oxide, nitrogen dioxide, 2PbO plus 4NO2 plus O2. And these are the brown gases. So you should show this brown gas wherever possible. You should show this. So these are the preparation of acids and bases from various sources. Now we'll start the chemical properties of acids. So remember, the chemical properties of acids we will learn more elaborately in our compound section. We have got few compounds, that is hydrochloric acid, nitric acid, sulfuric acid, ammonia. There we will learn much more detail, all the properties, chemical properties and physical properties of acids, bases. So here, when we are telling you acids, the first thing what comes in our mind is neutralization reaction, and it is applicable for bases also. So neutralization reaction. You all know this, you are learning this from your childhood, that is acids and base. So acid and base reacts together to produce salt and water. This reaction is called neutralization reaction. So we will take a few examples of that. First I am taking basic acidic oxide, say copper oxide, when reacts with a sulfuric acid, H2SO4, they produce, see here, copper sulfate. So salt, they are producing copper sulfate and the water. This is salt and this is water. So I am not elaborating too much because we will all discuss this in our compound chapter. Now I will take the example of another base that is NaOH. If this reacts with HCl, you all know these reactions will be NaCl, sodium chloride plus water. So this is neutralization reaction. Acid, and this reaction is this is also the chemical property of base also. I am compressing this chapter so that you will be able to learn it more quickly and more easily. Now metals have a very important reactions with active metals. Acids have a very important reaction with active metals, because we all know the metals which are placed above hydrogen in the activity series can replace hydrogen from the acids. So next is reactions with active metals. So you can write reactions with active metals. Active metals. So what are active metals? Active metals are those metals which are placed above hydrogen in the topmost position of the activity series. So potassium, sodium, zinc, all are example of active metals. So when active metals, I am taking zinc, when react with say sulfuric acid, so they can produce zinc sulfate, a salt, ZnSO4 plus hydrogen is liberated. That is very important. Say the same thing I can write, say magnesium. Magnesium when reacts with HCl, these are dilute acid, remember, they can produce magnesium chloride, MgCl2 plus hydrogen. So these are the reactions of acids with active metals. Now few reactions are there, that is when acid reacts with one salt to produce another salt. Acid reacts with one salt to produce another salt. Now the continuation of chemical properties of acids. A few acids when reacts with a salt, they produce another salt and an acid. Remember, these are few important reactions. That is, third property is when, let us assume NaCl. So if NaCl reacts with say concentrated H2SO4, I am taking it concentrated H2SO4, and the reaction is taking place below 200 degrees Celsius. Again and again I am telling, below 200 degrees Celsius partial decomposition, that is one hydrogen ion will be liberated from here. So here the yield will be NaHSO4, sodium bisulfate plus HCl. So another salt and acid can be produced. So if I take another example, say second example, say I am taking sodium nitrate NaNO3. If this thing reacts with H2SO4, sulfuric acid concentrated, again I am taking, the reaction is taking place below 200 degrees Celsius. So this is partial decomposition. I have shown you H2SO4 dissociates like this, H plus HSO4 minus. So here the thing that will be produced, the salt that will be produced is NaHNO3, sodium binitrates So sodium bisulfate SO4, and the rest is what? HNO3. So HNO3 will be produced. So here partial decomposition product is sodium bisulfate and nitric acid. Now when acid reacts with carbonates and bicarbonate salt, Other than acid, they will produce water and carbon dioxide. Again, I am repeating myself. When acids reacts with carbonate or bicarbonate salts, there they will produce carbon dioxide and water. So see these examples. So I am taking sodium bicarbonate, NaHCO3, when it reacts with sulfuric acid. So when I am and this thing you should remember. See here I will be taking dilute sulfuric acid, and the product will be sodium bisulfate and water and carbon dioxide. So the product we will obtain is sodium sulfate, that is Na2SO4, sodium bisulfate, plus for this carbonate they will produce carbon dioxide and another is water. So you can balance it like this, put a 2 here. So easily you can write, you know how to balance it. So this will be 2 and this will be 2. So remember one case when the bicarbonate salts reacts with acid, they produce carbon dioxide and water in place of acids. So if I take sodium carbonate, I have taken bicarbonate, now I am taking sodium carbonate, Na2CO3. Sodium carbonate when reacts with H2SO4, same thing will happen, H2SO4, again I am taking the dilute acid, the product will be, remember, the same, that is sodium sulfate. So you should write it like this. These are very important reaction and you have to remember it. So no way to escape, you have to remember it, that is water. So here you can see when there is carbonate or bicarbonate radical in place of acid, what is producing? Carbon dioxide and water. So, and remember, in time of writing the reaction, just this is for your knowledge. So for H2SO4, sulfuric acid, this is very important, H2SO4. So H2SO4, any reaction which takes place above 200 degrees Celsius, that means if the reaction is taking place more than 200 degrees Celsius, then complete ionization takes place. Complete ionization takes place. So what is that? So you can ionize H2SO4 like this. Remember this one. 2H plus 2 hydrogen ion plus SO4 minus 2. And if the reaction is taking place below 200 degrees Celsius, remember below 200 degrees Celsius, then partial decomposition takes place. Partial decomposition takes place. So in that case, only one hydrogen ion will be liberated. H2SO4 dissociate will be like this. H plus plus HSO4 minus. You can see in the formation of product, in these two cases, here partial dissociation takes place because the reaction is taking place below 200 degrees Celsius. But here the reaction is taking place above 200 degrees Celsius. It is also above 200 degrees Celsius. That's why complete dissociation takes place and the product is sodium sulfate. So we have done up to the preparation of acids and bases from few elements. Now one thing I have missed out, that is classification of bases. So classification of base. And remember, bases can be classified exactly like acids. That is a strong base, weak base, strong acid, strong base, weak base, then concentrated base, dilute base, almost same. One thing I'd like to add here, that is acidity of base. So it is acidity of base. So what is that? You all know this. That is the number of OH ion. So number of replaceable OH ion. So you can write number of replaceable OH minus hydroxyl ions in the solution. So according to acidity of a base can be classified into following categories. So you know these things. So first one is monoacidic base. Then I can tell that is diacidic base. And lastly, triacidic base or polyacidic base you can tell. So I can write triacidic base. So first is monoacidic base. What is that? It has got, this type of bases has got only one OH minus ion replaceable, one hydroxyl ion in the solution. So it has got one replaceable OH minus ion in the solution. So I can take example of sodium hydroxide in a monoacidic base. It can dissociate like this, Na plus OH minus. Say calcium hydroxide, you can classify calcium hydroxide as Ca plus OH minus. So you can see these are the bases. Sodium hydroxide and potassium hydroxide can only produce one hydroxyl ion in the solution. Now comes to diacidic base. So here this type of bases has two replaceable OH minus ion. So you can easily write calcium hydroxide CaOH whole twice. It dissociates into Ca plus 2 OH minus. Say I'll take example of MgOH whole twice. It dissociates as Mg plus 2 OH minus. So here in this type of bases, that is calcium hydroxide or magnesium hydroxide, you can see they can produce two OH ion in the solution. So two replaceable hydroxyl ions in the solution. Last comes triacidic. Tri means three. They can produce three replaceable OH minus ions. So here I will take the example of aluminum hydroxide AlOH whole thrice. In solution, aluminum hydroxide dissociates as Al plus 3 OH minus. So here it can produce 3 hydroxide ion. Remember, for monoacidic base, here the metals have valency of 1. Here valency of the metal is 1. That's why they are monobasic acid. Not that's why. So you can treat here magnesium and calcium has the valency of 2. So they are treated as a dibasic, and aluminium has the valency of 3. So it can produce a triacidic base. So these are the classification of base with respect to their acidity. Now we are getting into a very, very important part. You can see that is called indicator. That means there are few chemicals or few substances which will tell you that in a solution whether the acidic property is prominent or basic property is prominent or the solution is neutral in nature. So indicator are the substances which actually tells us about the acidic, basic or neutral nature of a solution. Normally in earlier classes we have learned about few indicators, that is a phenolphthalein, methyl orange, litmus paper. All are there. You all know the litmus paper in neutral solution they gives purple color, in acidic they gives orange or red color, and alkaline solution they give blue color. And for methyl orange, in neutral solution they give orange color, a solution like this, and acidic medium they give pink color, and in basic medium they gives yellow color. And for phenolphthalein, the neutral solution gives a pink color, and in acidic medium they becomes colorless, and in alkaline medium they are again becomes pink. But the main thing what we learn in indicator is a scale called pH scale. See here, it is known as pH scale. What is pH scale? It is, see, the strength of the acids or bases. The strength of acid bases can be measured with the help of a scale. Say if you take and the strength of the acid and base as a physical quantity, then its strength can be measured, its strength should be measured, and the scale which actually measures the strength of the acid and bases is known as pH scale. So it measures, it is a scale to measure the strength of acids or bases and remember, this scale is a scale which starts from 0. Remember, this starts from 0 and the midpoint is 7 and the highest point of the scale is 14. So remember, it is differentiated or graduated into 6 equal interval 1, 2, 3, 4, 5, 6, and it is like this. This is 8, 9, 10, 11, 12, and this is 13. So remember, this 7 scale reading is indicating 7 is indicates towards the neutral solution. Remember, it is the neutral solution. It is neutral. And remember, when you move towards this, the acidic nature of the solution will become prominent, and when you go towards this direction, that means right hand side, the basic or alkaline nature will increase. So in this direction, acidic strength increases. Acidic strength increases. So you can tell they will give you two solutions have pH value of 6 and another pH value of 2. Which one is more acidic? Your answer should be the pH value of 2 is more acidic than pH value of 6. Similarly, as you move towards the right hand side, the strength of the bases or alkaline nature of the solution increases. So here you can write basic strength increases. What is the meaning of that? If you tell a strength of a base is pH of 9 and another base has strength 12, so which one is more alkaline or more basic? The base which has pH value of 12 is more basic than the pH value of 9. So this is the scale. Now see from where it is coming. Remember, pH, this is not so important for your class 10, it is very important in class 12 and 11, is the negative logarithm of hydrogen ion concentration. Remember this one. pH value means the negative concentration, negative logarithm of hydrogen ion concentration in a solution. Similarly, pOH, this is called base, it is the negative logarithm of OH minus ion concentration. So remember, when we take water as the standard solution, water dissociates like this. Water dissociates into H plus and OH minus. Now see, remember the concentration of both H and OH is 10 to the power minus 7. Remember this one. It is 10 to the power minus 7 at 25 degrees Celsius. So concentration, remember, concentration of H plus at 25 degrees Celsius, it will be 10 to the power minus 7, remember. And concentration of OH minus at 25 degrees Celsius, it is again 10 to the power minus 7. So see here, this is called ionic product of water. So we can term it as Kw. Ionic product of water. Ionic product means the product of two ions. So I can write it easily, product. So it is known as ionic product of water. It might be little bit tough for you. It is the hydrogen ion concentration H plus and into OH minus ion concentration. So what is the concentration of hydrogen ion? 10 to the power minus 7 into what is the concentration of OH minus ion? Minus 17. That gives you 10 to the power minus 14. And see here, I have told you it is negative logarithm of hydrogen and OH ion concentration, and it is coming as 10 to the power minus 14. So we can write C, Kw ionic product equals to minus log of 10 to the power minus 14. And in log, this power comes in front. So this becomes what? Kw equals to minus of minus 14 into log 10. And I am assuming this is log 10 to the base 10, that gives you the value of 1. So Kw, that is ionic product of water, is coming as 14. That's why the pH scale is 0 to 14. So what is, to recap, what is pH? pH is a scale which actually measures or which actually tells you about the strength of acids and bases. And this scale starts from 0 and ends at 14. At the midpoint, that is at 7 mark, it is a neutral solution, not acidic nor basic. That is water. So as you go left from this 7 mark, the acidic strength increases. Remember, as you go left, the acidic strength increases. And as you go right, the basic strength increases. So I am giving you one example of this one. This is one question. The pH value of one acid, say acid 1, is 6. Another pH value of another acid, acid 2, is, I am telling 2. So which one is more acidic? 2 is more acidic than, so acidity of 2 is greater than acidity of 6, pH value of 6. Similarly here also I can take example that if the pH value of any substance is 9 and pH value of any substance is, say I am telling 12. So 12 is more basic than, it will be more basic. So remember this one. So in exam they can give you, say, 3 things. Say pH value of 3 solution is, say I am telling you 3, 7 and 11. Which one is acidic? 3 is acidic. 7, which one is neutral? 7 is neutral. Which one is basic? 11 is basic. So that scale helps you to identify whether a solution is acidic, basic or neutral. Now see, we have learned about the pH scale and different values of pH, where you can tell that which solution is acidic, which solution is basic, which solution is neutral. So remember, this has a very big utility in industry and agriculture, all there. So first of all, the pH value is very much used in agriculture. Why agriculture? Because due to some acid rain, you have learned, acidity of the soil is increased with the help of acid rain, due to the acid rain. So in order to make the soil neutral, so what we do, we use some base to that soil. So in agriculture, before agriculture, remember, before cropping, the pH of the soil is measured by the scientists or something like that. In dairy industry is very important. In dairy industries, to check the purity of milk, exactly. In biotechnology, remember, biotechnology, they are very useful. And medicine, very important, medicine. These are the factors. And remember, in agriculture it is used very properly to check the fertility of the soil, and in dairy industries to check the purity of milk, jam, all the dairy products. In biotechnology, pH have a very large use. And in medicine, remember, we are facing from acidity, and we just take milk of magnesia, that is magnesium sulfate. So what it does actually in our stomach, a neutralization reaction takes place that nullifies the effect of acids. So these are the few things. And one more important thing you should learn, that is, remember, don't forget the use of acids and bases. These are the things you should expect for your section A, that is 1 mark question. Uses of acids and bases. What are those? Uses of acids and bases. Remember, in your book a chart is given, small chart, that is boric acid is used for eye washing, citric acid for food preservation, oxalic acid for ink stain remover, carbonic acid for flavoring of soft drinks, tartaric acid is used as baking powder, acetic acid is used, that is vinegar, is used for cooking, hydrochloric acid is pickling of metals, and sodium hydroxide is manufacturing of soap. These are given and you have to remember this thing. No shortcut is there. Calcium hydroxide is used to make the bleaching powders, and magnesium hydroxide as an antacid, I have told you, that is milk of magnesia. And calcium hydroxide again has an effect of softening of water. In class 9 you have learned about hard water, soft water. And ammonium hydroxide for removing the grease stain from the clothes. So these are, remember, these are there for your 1 mark question in section A.